Okay, so this is Tony Cake from ImmersionRC, and he is here to show me and to give me so I can run some tests with this, the new ImmersionRC RF Power Meter. And this is a very exciting little device. If you're a nerd like me who loves measurement technology, I have a FLIR, I have a clamp meter, I have all this stuff, and this is great. But also, if you run races, if you go to races, this is a really useful device for measuring the power output from your video transmitter, your controller, and any RC device. And now you may know, look, it's right here, see? You may know that this has existed for a while. This is Gen 1. And what was wrong with Gen 1?
Nothing.
Come on.
I'll show you. So Gen 1, we used an external attenuator.
And the attenuator was the problem.
Well, what we did is we calibrated it at this point here, right, at the sensitive point.
Right.
So it's fully calibrated across all the range of frequencies. And the attenuator specs were promised to be, this is made by some, big company. They were promised to be, 30 dB or
plus or minus it was, half a dB or whatever.
Yeah, and it was actually plus or minus something much bigger.
Right. And that's the problem that you solve with this guy.
Yes.
So this guy has an internal calibrated load resistor. It's also way smaller. It has an internal battery, no plugging in of a little 2-cell like this one. It just turns on. And here, what are some things that we can do with this?
So 3 screens. First screen, we need a pointing device. But we've got dB power, milliwatt power, or microwatts in this case, there's no input, along with a little analog scale. In the top corner, it says in average power mode, which is what you need for a video transmitter. Analog stuff.
Yeah.
If you rock the joystick to the right, so this is our power scope.
Whatever. Switch warning.
So now bring the antenna up to your Taranis antenna, and you will see all the packets this thing is sending to your quad. And if you rock, I think, up and down, just like an oscilloscope, go down now.
You can sort of zoom in and out.
Okay. So this is showing, and you can see a number. You see it says 50% duty.
Is that the duty cycle?
So this means it's transmitting 50% of the time.
That's interesting.
Yeah.
We could compare that to the FCC specs, right?
Yeah. And what you can do is you can also look at, so this is 20 milliseconds, says the span end to end.
Right there.
So you can approximate how fast it's sending the packet. So when a radio manufacturer says, ooh, we're, latency and frame rate are kind of different, but, our latency is this, you say, well, okay, well, maybe it's not.
We can kind of check those things without having an oscilloscope or a complicated, expensive spectrum analyzer.
And the other thing that's interesting, there's a few tests you can do with this. One is, if you've done the mod that you've done here on your radio, and you've got a different antenna, you now have a tool which will tell you whether you actually did that mod correctly.
The power that's coming out?
Yeah, and it's approximate. I mean, you don't have a direct connection here.
Yeah, because we can see here we got minus 9 dBm coming out.
So if you go to another radio with a stock antenna, you can hold it about the same place, and you've got a comparison.
I've been saving this for literally just this occasion. This is ImmersionRC Tramp, fresh out of the box.
Is this where I cross my fingers? Is
This is not a trick. This is not an ambush, because you guys say that you calibrate each of these before they leave the factory.
We do.
So you should have nothing to worry about here.
Do you have a wand?
What? A wand? Yeah. No. Does it not have a push button?
Yeah.
It does or doesn't?
The push button sucks, though.
Now, in case anybody doesn't know who Scully is, who's Scully?
Scully. I don't know how to describe him. He's so many different people.
He's an announcer at races.
He's a rodeo announcer. He's a rodeo rider. He's a RC car announcer. And he's about the best FPV race announcer in the business.
Yeah.
So,
and we call it Scully Mode because it's used at races to check the output power of the transmitter.
So what you do...
Show me.
So we haven't calibrated it yet. So you take it to the right.
Okay.
Oh, maybe it's up.
Zero defined.
Now... So we've just defined a middle reference to be about this far from an antenna.
I see. So we hold it a fixed distance from the antenna, and we define by pushing to the right the zero reference.
Now, if you go to down your line of 8 quads for a race, and you just hold it up to each one once you've calibrated it, it'll roughly tell you the guys who are transmitting 600 milliwatts. And it'll also tell you the guys.
So you would take a 25 milliwatt quad that you knew was at 25.
Yeah.
You would define 0, and then you would walk down the line.
You walk down the line, and I'll remember it through power cycles.
Sure.
And the guys who are running 600 are immediately obvious.
Yeah.
The guys who are, their UFLs are disconnected or their antennas are dead, they're immediately obvious. And both of those people are a real problem for racing.
Now, can we use the push button to change the output power, or do you need a wand for that?
Yeah, you can change it. It's
a hassle. You don't have a wand with you, do you? I mean, you might.
I don't. I should have. Buttons should be outlawed.
Well, do you have the NFC app on your phone by any chance?
Not on an iPhone.
No.
Have you got?
I have an Android phone. Do you want to try to get the? Can we download it?
Just download it live.
Oh my gosh! So there's a what they call the wand for this guy. We need the antenna, don't we?
Yeah.
We'll need the antenna out
right
of the
there.
box. It's got this little antenna, which is an NFC. That's not a near field communication. It's the same as like tap and pay when you do tap and pay, and you basically can use NFC to configure this video transmitter, which is nice if you're at a race because the race director can have the wand, but it's also nice because your phone, if you don't have an iPhone, has NFC capability and you guys just released this, I think, recently, an app that makes it work. You have to kind of find where the
antenna's in different places on each.
You can tell it's there, but it's not entirely happy. Right. Oh, there we go. Successfully read tag. Okay, now
this, by the way, is why we didn't release this initially. Everyone was asking us why we didn't do it.
You couldn't.
Every phone is different.
Yeah.
Okay, so then just say 600 milliwatt.
600 milliwatt, and we'll get this guy working here in Scully Mode here. And I will write configuration. There we go. And what does Scully Mode say? It dropped, and boom, 20 dB plus 20 dB.
Yep.
So you're walking down the race line, you see this guy, he smashes quad with a hammer.
Exactly.
Yeah. And now this works. Now we're using it here in Scully Mode. We're using an antenna, but for the bench, and that's how I'm going to be using it, because I'm going to be doing a test with a whole bunch of different video transmitters.
Yep.
And showing which ones are accurate and which ones are not. And we can measure the power directly from the VTX, which is more accurate. The antenna will always have some losses and so forth.
Yep.
So now we'll go here. We'll put it back in this mode.
So put it on 25. That's
we want the tramp. Can we write the tag even with it powered down, or does it need to be powered up?
That's the point.
Yeah, okay, that's pretty. So we don't have to have it on.
Nope.
And that's the one thing that smart audio and tramp telemetry still don't do.
Yep.
Which is this NFC tag. I don't even have to power my quad on to set my channel and my transmit power. That's brilliant.
Yeah, that's why we did it this way. It's kind of the only technology that lets you do that.
Brilliant, because you write to the tag, don't you?
Yeah.
And then the module reads the tag after it powers up.
Exactly.
And that's really great. If you're at an event, they say, okay, everybody be at 25 milliwatts. Well, you're at 600 milliwatts, and they say, okay, everybody change channels, and then everybody powers up and is flying, and you were in the bathroom or something. Now what do you got to say? Okay, can everybody land so I can set my transmit power? And it was like, this is the only thing I know of that'll let you do without powering up. Okay. Well, pit mode is not as reliable as you would hope, though.
No.
So now we're at 25 milliwatts, and we're gonna, the moment of truth, we're gonna power this guy up, and we will see how many milliwatts we get. It's not powered up yet, I don't think.
Yeah, it is.
Is it? What does it say?
Oh, but you didn't set the frequency.
Oh, wait, we got to set the frequency. Yeah, of course.
Yes.
So I'll click the button. We're on race 1, which is 5658 megahertz.
That was close.
5650?
Yeah, it's close enough.
That's really close. Average. It's all correct, isn't it?
It's all good.
Oh,
okay.
Look at that.
26 milliwatts.
I'll give you that.
Is that close enough?
I feel like that's 1 milliwatt. That's pretty close. Yeah, I call that pretty close.
Can I uncross my fingers now?
26.5. I mean, ultimately, the people in the comments section are going to be your biggest critic. Yeah. I just show the data. 26 milliwatts. I am an RF professional, and I feel like if you promised me 25 milliwatts from a consumer-grade device and you give me 26 milliwatts, that's pretty good. Now, there you go.
Yes, that's about it.
There's the ImmersionRC new V2 RF Power Meter, built-in, calibrated, easy, correct way of measuring output power. It's really nice to see companies. Some people said, why don't more people make these? And I'm like, they do. They're called Siemens and Agilent, and they cost $3,000. And if you're so it's really nice to see people putting out consumer grade versions of these that are accurate enough to be useful to the average consumer at a price people can. How much is it going to be?
It's like $70, I think. $69.
Yeah. So
it's interesting that we calibrate it against, like in any test and measurement gear, it needs to be calibrated against a known source.
Right.
And the known source is another power meter by Roden Schwartz, which is about $3,000.
Right.
So we basically, in our test system, we compare the two and calibrate, because there's a lot of calibration data in this.
Yeah.
So it's basically the calibration of a $3,000 meter.
Right.
Which you wouldn't want to take to the field.
No, you wouldn't. So good. All right. Thank you so much. There you go. Link in the product description.